Hey guys, this is Miss Regine from SOAR Educational Services, and today we're going to be going over some trigonometric problems. You might do this in a pre-calculus class also. The first thing we're going to do is to change from radian to degree or from degrees to radian. So angles or unit circles, they can be measured in degrees, which you guys are used to, like 90-degree angles, 60-degree angles, or they can also be measured in radian, which is where pi is used. And you can compare that to measuring something in inches versus centimeters. So just different units that we use to measure something. Okay, so the first one is written in radian. So it's negative 17 pi over 9. To change from radian to degrees, what you would need to do is multiply top and bottom by 180 over pi. So now your pi's will cancel, because that's just an algebraic rule that when you have the same number on top and bottom, they cancel. So the pi's cancel. So then we can just multiply negative 17 times 180. And that's negative 3060 over 9. And now we can divide by 9. And that's negative 340. So this one is negative 340 degrees. And when the degrees are negative, and we'll talk more about this a little bit, but it just means that you're going to go in a different direction. So you're going clockwise on the unit circle when it's a negative degrees. Now 585, very similar. You're going to multiply by pi over 180. All right, so, and that's because 1 radian, 1 equals 180 degrees. So this one, we're going to multiply 585 times pi, and that's 585 over 180 pi. But we do need to simplify this. So think about your fractions and greatest common fraction. Let's see. I don't know if this is in simplest form yet. So I think it is. Oh, no, maybe not. So we want to make sure we simplify our fraction. Okay, yeah, it's not. So it's 13 pi over 4. So that might give you a little bit better idea of how much this is now. But this would be the measurement in radian. So now let's try some other one. Here it says, draw an angle with the given measure in standard position. Okay, so if you have your unit circle and you have 26 pi over 9. Now you can definitely change this to degrees if you find that easier, and I can definitely understand that, because that's can be easier to think about. But let's say you have to stick to radian. So let's see how we can practice radian. So you have your 0 degrees. This is pi half. This is pi, 3 pi over 2, and 2 pi. Okay, so, and we have 26 pi over 9. If we think about breaking our unit circle into 9 parts, when we get to one whole, we'll be over here. Like this will be 9 pi over 9. Oh, sorry. 9 pi over 9. That's one whole pi. It's 9 pi over 9. Because initially it was just 1 pi. Now we know that if we have 9 over 9, that's the same thing as 1. So this is 9 pi over 9. So over here where I have 2 pi, if we're making the equivalent fraction for that, that's going to be 18 pi over 9. So now we have 18 pi over 9. If we went a full half the circle again, that would be another 9, which would make it 27 pi over 9. But now remember, ours is 26 pi over 9. So we can think of it like, if this is my starting position, I've gone 18 pi over 9, and I'm not going to go all the way down to 27 pi over 9. But imagine breaking this up into 9 parts. this quadrant. Well, I'm sorry, not these two quadrants, if you broke them up into 9 parts. So maybe 26 pi over 9 would be right here. So this would be our angle right here. Now, we can do more about as far as finding the reference angle, how large is this angle really, but for now they just wanted us to graph it. So we have done one full circle, like we've gone around the loop one time. That's 18 pi over 9, but we didn't, and then it would have been almost 1.5 time, but we stopped short to 26 pi over 9. Okay, now here's another one. This one's in degree, but it's negative. So it's negative 690, and they do have negative radian also. So don't think that you can get away with it with radian. They do. Okay, so now with the negatives, it's the same idea except you're going backwards. So it's going clockwise. So this is negative 90. This is negative 180. This is negative 270. This is 0, but then when you loop one time, it'll be negative 360. So now we're trying to get to negative 690. If we double that, okay, so no, that'll be too much, so we're not doubling. So if we're at negative 360 and we add another 90, that's going to be negative 540 right here. Negative 600, because each quadrant is 90 degrees. So this one would be a negative 630. So negative 690, and degrees much easier, for me to comprehend like how large this angle is. So if I'm at negative 630 right here, to get to negative 690, I just need to add another 60. So adding another 60, this is my angle. Let me show you like our loop. So we started here, we did this, and then stop right here to draw our angle. Now, if we're talking about what the reference angle is, it would be a 60-degree angle, because that's how large this is in this quadrant. We went up 60 degrees from negative 630 to negative 690. We went up another 60 degrees. So it's a 60-degree angle, and whatever else we needed to know from that, we could figure it out. Oh, okay, so actually that's our next section where it says find the reference angle, 9 pi over 7. Okay, so if we have to find the reference angle, we have 9 pi over 7. So again, this is pi half, this is pi, this is 3/2 pi. And here we're at 2 pi. Well, this is not going to get us to 2 pi yet. But if we get all the way right here, this is 7 pi over 7, because that's 1 whole pi. And now if we want to do 9 pi over 7, it will be about right here. So now if we want to know, okay, well, how large is this 9 pi over 7? All right, so we're trying to find out how large is 9 pi over 7. Now we have gone 2 pi over 7 spaces. So, but we want to find, so here, that will tell us like how far, like how large the distance is for that. It's not one of the common ones. So if you had something else to do with it, you might have to use some other trigonometric rule. But for now, if we just want to know just how large is this, it's 2 pi over 7 large. We're going to do one with degrees that will probably be a little bit more concrete. But just to find it, you just find the difference between what you were given. So I'm talking about that previous problem we just did. It's in the third quadrant, so you find the difference between the angle you were given, which was 9 pi over 7, and our closest quadrant line, like our closest quadrangle, which was pi in this case, which we convert to 7 pi over 7. All right, but let's try this one, negative 230. So for negative 230, Um, we are going to, okay, so it's same thing. Yeah, negative 90, negative 180, negative 270, negative 360. So we have negative 180 right here and a negative 270 right here. So I know it's in between there. This one's easier to navigate through because I can say, well, I just need to go up 50 more. So this is negative 230. So the difference between what I was given and that closest quadrangle, like right here, is 180. Now, if here's a little trick. If something falls in the first quadrant, that's going to be it. Like whatever that angle is, that is it. Now, if it falls in the second quadrant, you do have to subtract. I mean, a lot of it you can use mental math and just use common sense and see, well, what is it really? So because there might be rules like, is it negative 280 minus, yeah, I think it's negative 280 minus negative 180. Yeah, so that gives you negative 50, but you can just say it's 50 degrees. But you can think about, okay, I'm going to subtract what I've been given minus this angle right here. If it's in the third quadrant, I think it's similar, what I've been given minus this angle. Make sure it's the positive version of it. You know, if you just want to know what the reference angle is. And then if it's in the fourth quadrant, usually you're going to compare it to the 360. So, okay, well, how much more do I have to get to 360? Or if it's in radian form, how much more do I need to do to get to 2 pi? All right, so this video is getting pretty long, so I don't want it to go on too long. So we're going to stop here. I hope this was helpful. If you liked anything or found it helpful, please like and subscribe to this video, and I'll see you next time. Bye.